All right. Yes, the one we got on Tuesday. Whatever we got on Tuesday is the one that's due Friday. All right, so 2B.1 part B, continuing with residuals and practicing. So the difference here is that they gave us multiple tables. So your biology teacher has bacterial cultures for a class of 24 students. Each student is measuring the number of bacteria Y in his or her culture at intervals of time X hours during the day. The results are shown in the table and in the scatter plot below. Okay, so if you were given this problem, is basically asking you, are you comfortable finding regression models to model this behavior? That's what that's all you have to be able to do is be comfortable finding the regression models to model the behavior that you see here. So we have one student set of data. Well, all the students set of data. It's just one long list, but you get it. Everyone gets it. Right, go. And so once you put those values in and then find the best model fit, we can waste class time and go through it together and practice typing all of this in if that's what you want to do. But ultimately it's just making sure that we're okay putting this in the calculator, turning on our diagnostics, finding your R squared, and determining the best fit model. So I'm going to let you guys determine what you want to do at this point with part B, or do you feel confident enough that we don't have to dive so hard into this part?
Just do like the first 5.
Yeah, you want to just model it out with the first 5?
Yes.
Okay. All right, cool. There we go. So we're gonna go let me go grab Sylvie here. Here she is.
Different data sets?
No, it's one. It's just 2 different. It's a double table because it's a long list. It's a class of 24 students. So it's 12, 12. All right, so are we just gonna go to 1.7?
Yeah.
All right. So practicing putting in the information. Cool. So we're gonna go to stat, edit. We're gonna have 0.5, 0.7, 1.2, 1.5, 1.7. And the number of bacteria they had is 200. Then they had 196, 342.
So we're choosing, it's not
390. 476. All right, so we've put information in, right? And it says find a power function regression model and the coefficient determination. In order to have that coefficient determination or R squared, we have to make sure we turn on our mode. So we go to mode, and we're going to go down to where it says stat diagnostics. Where it says stat diagnostics, we want to make sure that it is on. Anytime you're comparing and trying to see if it's the best fit, you need your R squared. And the only way to get R squared without having to do it by yourself is making sure it's on.
So can we just like always keep it on and have it?
You can. It used to always be on, and then for some reason, Texas Instrument decided we're going to now give this an off feature. So it's on. Now I'm going to run power. Now, the power function is a pretty cool function. The reason why the power function is pretty cool is because it goes through basically determining whether it's linear, quadratic, if it's a cubic, if it's a quartic, if it's like, it goes through the different powers, right? And it'll tell you from there. So I'm going to go here. I'm going to go down. The power is A. So you got to go all the way down there, or you could press alpha A, but scroll or press alpha A, either way. But power regression, and we're going to hit enter. I do store just in case I need a reference back to it. So it's also good practice. Vars, Y vars, 1, 1. I'm going to say this is 1, but if I have another one, it would be 2, right? So when I calculate this, it's going to give me values. So based on what it says here, it is basically almost a linear. And that's
Yeah,
because
when I did linear, it's closer to the R squared is better.
Yeah, it's basically almost a linear. And why is that? Because look at the power. What is your B value? 0.748, right? And so that's basically pretty much almost a linear model, if you think about it in that sense.
So this comes right, that's why our answer that's telling us like what.
It's giving you, it's helping you narrow it down with the power. Yeah. Huh?
Because the B, the.
Your B?
For our exponent, so in a linear, the exponent of 1, right? And that's what it is. Wait, this, I'm the exponent. Right, for this, the R squared is 1. Like I did all of them to see which R squared was higher,
Yeah.
and the closest was what? That's weird.
I don't know. I don't know. So,
Oh, it is 1. The R squared is 1 on, but if we only test linear, don't you have to test all of them?
no, you're only testing what it's telling you. It told me to test a power function. It said find a power function.
You don't have to find the best fit one?
No, just find the power function.
How do you, what's, the power, like just a regression?
Yeah, it's just a power regression, just saying this.
Could've done squared. I could've
Yeah,
done-
it's just, it's asking you specifically run a power function model.
Power function is like an octave.
Yes, it's
Like
asking you
that
to,
linear.
yeah, it says power. It's actually, it's the,
one on my-
yeah, that's why I say it's, you have to either press alpha A or scroll all the way down.
I don't really do power regressions because they're normally like wrong a lot of times, so like weird.
But if it asks you for it,
But that one's right.
so it asked us for it. So right here, we get y hat is approximately 299,119. And it's gonna be x to the 0.748. And the R squared here is 0.934.
So how did you do? How? When
So,
you're- like, how did you say when
same
you-
way, just scroll down or up, either way.
If there's an A, is it?
It's A. Okay, so this R squared is, and again, this isn't a true assessment of the whole class, right? Because we put in their entire class data. No, we did not. We only chose the first 5 and said we're gonna just practice putting things in the calculator using the first 5. We agree? All right, so now if it asks you again, well, what about an exponential? What's the difference between a power and an exponential model?
Exponential.
The what? The B and the X are switched, right? Basically, that means that your exponential, your variable is your power, right? Okay, so now when we do an exponential model, the variable becomes the power. Okay, so running that model, we have stat, calc, and that's going to be 0, or you can just scroll down and press 0 or scroll up. However, it's a looping circle. It goes all around. So I'm going to press exponential. Again, I like to store it. Do you have to store it? No, but it's good practice. And this time, this is my second model that I'm creating. Vars,
No, like, what, no, like, what do you?
exponential. Go. And so then it writes it.
Is that quad, right?
I did exponential. Scroll down. So now for this one, it says y equals, what are we at? 763. To the x. And what is its R squared? So if this is what they had me comparing it between a power and a exponential, based on what it's asking me to compare, which is the best?
Or with the exponential?
The exponential. Why is the exponential the best? Your R squared is closer to 1. So the best model for the 5 that we did, because remember, we only did 5. For the 5 that we did, the exponential is the best model between these two. Only because that's what they asked us for. okay? It's gonna be narrowed down. It's not gonna be like, out of all the functions in the world, test and see which one works, okay? There's no way that they can do that on a time test, and you have to figure out or guess and check between, okay? But do we feel comfortable putting them in, running the test, making sure our diagnostics is on? Or do we need to keep practicing? All right, so let's talk about why I store both. Because inevitably, there's going to be a question that asks you to make a prediction using your models, right? So if I already have these models and I've already stored them in my calculator, I can easily use the table that exists to evaluate. So it says here, discuss the endpoint behavior and the left-hand endpoint behavior. So when we look at our points, they would look something like this on the calculator, right? Or they do. The endpoints are heading the right direction. The models both could be closely represented. That's why the numbers are fairly close. All of this is possible. Everything is good to go. And it's only because it's a snapshot. But it tells us using the exponential model, right? Find the number of bacteria in the initial sample, make a prediction for the number of bacteria present at 24 hours. So if I'm looking for the number of bacteria at the initial, that means X equals what? 0. So using our exponential model, and our exponential, was it our first one or our second one? Our second. So for us, that's going to be Y2 in the calculator. Does that make sense? Because we stored it as our Y2. So we're looking for, when does Y2, what is the value of Y2 at 0? And because we stored that in our calculator, we just have to go look at our table. So we're just going to go to our table. So I'm going to go second graph, open my table. And what is the value of Y2? 126.76. And if I hadn't stored it, I would have to go and take what I wrote down and go back to it. But practicing storing it is ultimately, you're going to probably need it again. Okay. They're going to always, well, generally come back and ask you a question. So we get that our initial value would be 126.76. You could go back and plug in.
Okay.
Yeah.
If we, but isn't it like, so like we just, instead of going to like second table, we just go to stat and.
You would just rerun it again, but if you store it, then you don't have to run it again, and it's already saved in your Y1 and Y2. I only wrote 2. I was lazy. My bad. 3. I was lazy. I admitted it. All right. It says, what about 24 hours? Well, could I also use the table to calculate 24 hours? I surely could. I would probably take, it's a big number, isn't it?
It's to the 10, it's times 10 to the.
I would write it in scientific notation. How would you?
Yeah.
Yeah. So times 10 to the.
Yeah, 1.5 times 10 to the 10th power.
I'm going to go second table setting. I don't want to scroll and go to 24. I didn't want to scroll. Okay. Let me be me. So for Y at 24, we end up with 1. Well, it's just Y2. I'm looking at the Y2. Yeah. It is, can I write it in millions, and is that okay with y'all? 1.5. Well, times 10 to the 10, whatever that is.
Yeah. Like I looked at it and I was like, I'm not ready.
Yeah, times 10 to the 10. Okay, now it says here, now going backwards, it says, when will the number of bacteria reach 10,000? So it's asking you, when would the number of bacteria reach 10,000? So that's where we're going to talk about, remember, our intersections. Okay, we're going to delete the one that we do. Oh my gosh, you are so smart. Oh, great.
Wait, what is that? That like
1.5 times 10 to the 10. It's this number that I didn't want to write all the way out.
know that though. Why do we need that? I thought we just needed the 126.
And it says present at 24 hours. The next part.
What is 1.6?
1.6? That was the initial. Like at
That
zero?
was at zero.
At zero, that was the number of bacteria. We did find zero. It's all the same question. All right, so I don't need Y1, so I'm gonna just change Y1 to 10,000. Is that okay with y'all? If not, it's happening. I do need 10,000 though. I want to know, when will I be at 10,000? Okay, I'm gonna have to change my window. I clearly am not gonna have a large enough Y value to be able to see that. So changing your scale is gonna be important unless you just want to keep zooming out. It's really up to you, but I don't want to do that. So I'm just gonna put a ridiculous number here just to make sure I see a line go across the screen. So it's gonna graph. I went too high. I need them to touch. Are they touching? That's it. I changed my Y scale to 1,000. You can't find an intersection if you don't see it. Okay, all you need to be able to see it. And then what do I press for the calculator to do the rest of the work? There we go. Intersect. And it's like, you really want me to find it? Yes. You're for real? Yes. Are you sure? Yes.
No, you don't have to move it all.
Mm-mm.
Sometimes you can use zoom zero to the zoom ten.
Sometimes it's nice.
Sometimes it works. 5.6.
Okay. How do we feel with the calculator usage? So approximately how long? 5.6.
There's more decimals, but like.
3.
hours.
Approximately 5.63 hours. Okay, and again, this is just for the 5 points we used, right? 200,000. I just, I just,
Like all the way at the tippy top.
Yeah,
Look at
yeah.
yours, like,
Uh-huh.
barely
I did 200,000. I just wanted to make sure it was gonna be there. All right,